There's the question to us about Newton's method, remembering that the next value of x is equal to the last value of x minus f of x over the derivative. Now we can use it to approximate values of the x-intercept. Therefore, we're wanting f of x to equal 0. So if I used f of x equal to x squared minus 15, in Newton's method, we're setting that equal to x squared minus 15. That's what we're trying to do, to find where f of x, which is x squared minus 15 equals 0. If I rearrange that, that says 15 equals x squared. That's actually x equaling the square root of 15. So that by using f of x equals x squared minus 15, I'm approximating, well, x equals, we approximate the square root of 15. So that's done part A. So in this one here, I'm going to say that x1 is equal to 4. So I'm going to define, and I know it's going to be x squared minus 15 because I'm approximating root 15, x squared minus 15, and I'm going to define that. And then I'm going to make 4 as my first guess, and then I'm going to say my next answer will be x minus fraction, and on the top I'll have f of x, so I'll grab f of x and I'll copy that, paste, and down the bottom I'll paste, and I'll take the derivative of the bottom, so in line f2 with respect to x, and I'm going to make my answer for x my last answer, so I'm going to make it worth the answer. So x is going to equal the last answer. So x1 is 4, x2 is 31 on 8, x3 is 1921 on 496, etc., etc., etc. So to the first question, state x2 equals 31 on 8. And I might do some decimalisation now. 87298, and I'll press it again. We'll go to 5 decimal places, 87298, 87298, 33. So 87298 will be my answer to 5 decimal places because it's not going to change. The 3 here won't make that 8 become a 9. So 87298 is the approximation, 3.87298. And to the second half of the question, explain why these values are not good values to choose when approximating f of x equals 0 when x is bigger than 0. So I'm approximating for this x-intercept. If I choose equals -3, it's going to find this answer, not this answer, is not good because it will approximate the x-intercept when x is less than 0, not x is bigger than 0 like the question asked. And the problem when x equals 3 is the gradient at x equals 3 is equal to 0. Therefore, it's a terminating sequence because f dash of x when x equals 3 equals 0, therefore undefined because my tangent line will be horizontal, will be parallel to the x-axis, and I won't have the next value because xn has to equal xn minus 1 minus f of n minus x minus 1, n minus 1, and my derivative down the bottom here, that will be 0. Therefore, I've got an undefined problem. So that's question number 2.